Hi boys and girls, it's me Butch. My name is Terry David Silvercloud. I go by Butch. Today is the 11th of May. It's a Friday, bright sunny morning here. I have chronic pain issues and I get worried about my health, so I'm trying to make a whole bunch of videos about my thoughts and ideas in case I don't get around to writing them all down before I croak, which I don't expect to be a long time away. But you don't need to know about my private life today. I'm here to talk about an issue that was an error made by Einstein. He made a couple of errors when he worked on relativity. I want to quickly mention theories. His ideas are theories. They are not yet proven. There are some people that think they're proven, but they aren't. In the world of physics, there's a lot of false equivalencies, false analogies, and fallacies of ambiguity. Many physicists graduate with a basic physics degree, even perhaps some PhD candidates who don't actually study Einstein. They learn the numbers, they learn the formulae, they can crank the numbers, they can do the math, but they never actually read Einstein's 1916 version of Relativity, where he made some serious oversights. So a theory is a theory, not yet proven. Big Bang theory is so full of holes, I can't imagine why any intelligent person would fall for it. But again, it's what's taught, and many ideas are just based around the idea that Big Bang is fact, when it's a really crappy creationist theory. Oops, I'm sitting close to the camera because I'm going to have to show you some crappy drawings I made to explain myself. In 2017, a massive black hole so large and so far away was discovered that it would be impossible for Big Bang theory to be correct. Universe expansion is easily explained because we're inside the Milky Way galaxy and we're moving 7 billion kilometers per year towards the center of the galaxy on a long helical path. We'll reach the center of the galaxy one day and Earth will be no more. It'll be no more long before we get to the center, but not getting to that one. Anyhow, everything always seems to be going away from us, especially in our galaxy, which is much of what we see, because it is. We're falling into the center of the hurricane going through space that is our galaxy. Many of you may think that the solar system is just sort of some island out in space that we can go away from and come back to, but it's not. It's hurling. Earth is hurling along with the sun at 7 billion kilometers per year towards the center of our galaxy. Nothing ever goes in a circle. I've made another video about that, fixing Einstein, the path of Earth through space. Maybe I'll leave a link in the description and you can find that. So Earth makes a helical path through space. Nothing goes in a circle, and it can't because of something called absolute motion, which Einstein ignored. He tried to fix it with Lorentz Transformations, but it's still a relative field. Anyhow, I mentioned that theories are theories and not yet proven. Big Bang is a ridiculous theory, and you should start looking at other things. I noticed a couple of years ago when I was first reading Einstein, I came across time dilation, which is just an error in thinking. That was one of Einstein's big boo-boos. You can't make time be a variable, because if time becomes a variable, all of your equations involving time have infinite outcomes, and it just doesn't work. You can't change inches after the fact. You can't change feet after the fact. Any of your measurements are measurements, and changing them to suit your needs is very foolish. So time never speeds up, time never slows down. It's just a matter of perception of time. And there's a strong possibility that increasing the acceleration of objects may cause them to behave differently, which would readily explain why atomic clocks don't always keep the same time at different altitudes and different places. atomic clocks at the North and South Pole should be different than atomic clocks at the equator. According to Einstein, even, they should be different, and that's because the equator is moving at 1,000 miles per hour, and the poles aren't going anywhere. They're just turning on themselves. Like, they ain't going nowhere fast. They're going with the Earth, but they ain't turning much. So there's other reasons why atomic clocks may change time rather than even Einstein's prediction. And the idea that gravity bends light can also be shown not to be correct, because those things are done when they watch stars passing close to the sun. And the sun, although the sun may be this may be the sun, but there's lots of crap around it near the sun, and we're way out. I can't even get in the camera. We're 93 million miles away. But in the immediate area of the sun, there is plasma, and the point being that space is not much of a vacuum for several 100,000 miles out from the, probably for the first million or so miles out from the sun. The space is much denser than the rest of space out there, and light always bends towards the denser medium. So even without gravitational effects, we should have expected light to bend towards the sun, just to prove that there's stuff in space. So where am I? Today I want to, I'm up to 6 minutes. I'm just going to yak. I'm a bit ADHD, and I wander and I talk too much. I mentioned that the explanation for time dilation in physics for dummies is absolutely incorrect, and I really don't have time to go into why it's incorrect. Maybe if you follow what I'm talking about today and you were to look at that and other explanations or so-called explanations for time dilation, you would begin to grasp why the explanation is just total bogus for people who don't really grasp motion. I'm 73, but when I was 22 years old, I was a naval navigator. I was the dude navigating the ship, and if I got it wrong, I had over 300 lives in my hands, depending on me, to know where I was and when I was there, because I was a dude that told everybody else where to go. I drove HMCS Cape Scott out of Bermuda with 3 rudder movements. Even the pilot, which was compulsory, it was compulsory that we had a pilot standing right beside us, and the captain standing beside me, but I was driving the ship, getting out of the reef that surrounds Bermuda, and I did it in 3 rudder movements. You have to do a long curve. Anyhow, I'm just showing them I'm a really good navigator and a really good driver of ships. I also was a submariner. I drove submarines. I was in the Navy. Where was I? See, I have ADHD. Yak. I'll at least try to be entertaining. I recently made a video about the cause of the speed of light, and I'm working on a grand unified theory and a theory of gravity. I believe gravity is push, not pull, and once you understand the electron and why the electron sets the speed of light, it rapidly becomes clear, if you're a thinking person, why gravity is push and not pull. The math works out the same, so that doesn't really matter much. You can keep using the same old math. Just like we have no idea what causes gravity, but we have all kinds of rules and laws around it from the time of Newton. I don't know if I mentioned Newton. Sir Isaac Newton, who gave us a lot of our basic laws. Isaac Newton recognized that there had to be absolute motion and absolute time, and he stated in some of his writings that we got to get over worrying about that, because we have no way to measure either one of them. And everything, Isaac Newton said this long before Einstein, that everything would have to be relative motion, and they had no idea what light was, so he wasn't even studying light. But Sir Isaac Newton grasped that everything was relative, and he acknowledged that all of his equations were relative to some point that you just determined was your start point, and everything else would work out fine if you just worked from that point. You could tell where you were going to be. You could tell how fast you're going to be there. You could tell how hard you're going to hit things, all that kind of stuff. Newton worked out years ago. And then Maxwell, who gave us our first electrical laws, he actually included a Lorentz transformation as part of his overall laws. So Maxwell came across the Lorentz transformations before Lorentz did. And what the Lorentz transformations is that because we can't allow for absolute anything, everything is measured from a particular field that we start with. This could be a cube if you choose, an inertial. Where am I here? Gotta look at the camera. This could be like an inertial field, a cube if you wish, and if it's moving through space, we could just, as long as we know everything within that particular, whether it's a flat surface or a cube, we could predict what would happen within that flat surface or the cube at a particular point in time further on. That's basically what a Lorentz transformation does. It fixes the math because we already knew we were moving. But one of the things that when Newton was doing his early mathematics, he was always dealing with what I'm going to call vector math. And a vector requires a direction. That's the main component of a vector. It always requires a direction. That's why it's a vector. You go that way, go that way, go that way. It's a vector. And most of our forces are vector forces that we measure, unless it's something like pounds per square inch, where we're measuring a vector force of the weight of air. You can't see that, down upon something. Einstein, in his 1916 Relativity, used the idea of a person standing by a railroad track and how that person standing beside the track would view events differently from a person riding, oops, gotta watch the screen here, riding in I'm so close to the camera here, somebody riding on the carriage would view things differently. So if he made these little drawings, basic drawings, and sort of like this kind of thing. Can you see that? There we go. So there was an observer. Let me get over here. There was an observer watching a railway carriage go by, and they were watching a flash of lightning at one end and a flash of lightning at the other end. And how each observer, if this was a passenger, if that observer was directly in line with the observer by the track, how the speed of light might vary for each of them using basic math, and then with some fancy calculations, with Lorentz transformations, he came up with all these, basically a lot of these relativity equations. But he was only dealing with things that were directly ahead or directly behind. They couldn't be off on some other angle. He completely ignored, on purpose, absolute motion of the observer. This guy is standing on the surface of the Earth, and we have no idea what direction he's traveling in space, nor how fast. We could calculate how fast he was traveling on the surface of the Earth if we knew his or her coordinates. With a GPS, we could say, okay, well, the Earth that's latitude, longitude, and the Earth is turning such and such miles per hour, kilometers per hour, all that kind of stuff. So Einstein ignored all that. He ignored absolute motion. The other thing he ignored was Doppler effect. He took light as all colors traveling the same velocity, and they do. But there's a big problem there. A red wave takes much longer to get from here to there than a blue wave. Multiple blue waves could pass the observer in the same amount of time that a red wave would take. If this trucky thing was a red wave, it would take longer to go by than a ball. You could get multiple balls going by against one big tractor. He didn't take that into account at all. Zero. So he completely ignored Doppler effect and lumped all light into a group because it had the same velocity. And of course, he and everybody else rapidly realized within the next 20 years that all electromagnetic waves travel at the same velocity. So a gravitational wave, which could be kilometers long or miles long or billions of miles long, the galaxy is being held together by very large gravitational waves, which would take a long time. One wave could not pass in 1 second, some of these gravitational waves. So measuring the speed of light against 1 second becomes a problem. And that's why I wrote my theory about what causes the speed of light when I began to realize that. And that you need a smallest unit of something, which is upon which you are doing the measurements. And we live in an electronic world, and absolutely nothing can happen. No message can get from your eye to your brain or from your finger to your brain, except by getting past an electron, getting from here to there. So the electron either has to vibrate or rotate or move. And the electrons don't actually move at the speed of light because it's one in, one out. The electron at the other end, however far away it is, pops out at the speed of light, but the actual, in direct current, the actual electrons aren't moving that fast, which is why I point out that our unit of everything that powers everything, including our brains, is set by the electron. So even if something is happening faster than the speed of light, we still receive it at the speed of light, and there's nothing we can do about it, which leads to the possibility, can things travel faster than light? Well, in theory, they can, but because of the amount of energy needed, and I don't have time to explain that, they can't. But if we theorize that they could, then we should think about that. Now, if this was the electron and smaller particles were hitting it, it would, and enough of them were hitting it, it would start flowing along the stream with the smaller particles that were hitting it. If they were very long waves, it would be caught up with it and move along with it as well. But it might, if they weren't long waves, the long waves would just carry the electron along. It would not be able to resist. It doesn't have enough mass to stop a long wave carrying it with it. But if it's just smaller waves, smaller particles than itself hitting it, then it doesn't really have to move. It could just roll with the punch and let the little guys roll over it. So all it would have to do is just keep rotating, and it would be good. It wouldn't really have to get out of the way. So I believe there are smaller particles I call quantum particles, or not quantum particles, gamma particles. Sorry about that. Gamma particles, and the gamma particles as a solid take the shape of a tetrahedron, and that the electron itself is an icosahedron, which is 20 tetrahedrons with a common apex or singularity, which makes why electrons work with quantum physics. And it also makes it very easy to follow them around. We just follow their singularity. Up to 18 minutes already, and I haven't come to the whole point of all this. So let's do a little bit of general relativity here. I'm going to move a bit closer. This is, relativity happens all the time in your life. You just aren't aware of it. Ballistics and navigation all depend on relativity. So if this is a truck going down the highway at 60 miles per hour, it's traveling at 88 feet per second. Now if the person here tosses a ball towards the back of the truck, this is an inertial field moving, and they are at rest within this field. So you clearly will see the ball travel towards the person at the back, and the person at the back will catch it. What happens if the person at the back, am I on the screen? Got to watch what I'm doing here. If the person at the back throws the ball towards the front of the truck, you clearly see it travel and be caught by the person at the front of the truck. But what really happened is while the truck was traveling down the highway at 60 miles per hour, the ball had that inertia added to it. At rest, it had that additional force added to it. So the ball is already moving down the highway at, you got to watch the screen here. The ball is already moving down the highway at 60 miles per hour. What the pitcher does is apply enough pressure. You know what, I'm doing this backwards. I wanted to show you what happens when it's going from this direction to that direction. Boy, there's a screw up. So imagine this guy here throws the ball. That's what this is about. This, we want to go against where it's going here. So the ball back here, when it's thrown, this person here applies enough pressure against the 88 feet per second so that when the truck catches up to the ball, it's exactly where it should be. I really blew it trying to explain that. I hope you can get it through your heads again, because this is really, really important. If the person at the front of the truck tosses the ball to the back, you see it go to the back, but the ball never goes that way. It just never goes that way. It just slows down in space just enough to counter this force so that when the truck gets up to here, the ball is exactly where it should be and the catcher just catches it. But when it's the other way around and the person at the back throws it to the front of the truck, the ball relatively does have to pick up speed in order to get from there to there. It's already traveling at 60 miles an hour, but if it's not thrown, it'll just still be there when the truck is further on. When the truck gets further on, the ball will still be in the hand. But if the pitcher applies some extra pressure, it'll travel relatively to the catcher, and it'll be there when the catcher catches up. Now, I'm not even worried about the observer here at the moment. The question arises, if the truck were traveling at the speed of light, then the inertial speed of the pitcher would be the speed of light. And we're not going to talk about relativity at all here. What happens? What is this velocity? Clearly, it must exceed the speed of light. Now, to the observer, the observer, if this is a glass cube here, the observer would simply see the ball being tossed back and forth. But the observer, in order to observe what was going on, would also have to be traveling at the speed of light, which is the fundamental error in physics for dummies. Is they don't point out that the only way you could even observe what's happening at the speed of light is the observer would also have to be traveling at the speed of light. You would not be able to observe it. You would be left behind so fast that what was happening, you couldn't observe it. That's the fundamental error in most time dilation things. They forget that the only way you could even possibly observe what was going on is to already be going at the speed of light yourself. And that's, gee, I hope I got that through. The whole point of this video is, and I've been up to 23 minutes, is that in theory, an observer traveling at the speed of light themselves, with a truck also traveling at the speed of light, and we're not even going to worry about, well, light here, the message can only get from the truck to the observer at the speed of light. So if the observer was standing still and the truck was traveling at the speed of light, the observer would just see the truck vanish into nothingness, the future as it were, which doesn't really happen because light could never travel backwards fast enough for the observer to even observe it, which is the problem in most time dilation things. They haven't thought about that problem. What's really fundamental here is it's theoretically possible to exceed the speed of light, but in practice it would be impossible because the speed of light, which is our standard of measurement, is set by the electron, which is so small that you just simply can't. I know this is hard to wrap your mind around, but this is all very clear to me, and which makes it difficult for me to explain because I see it really clearly, and I have to think, well, how am I going to explain this? I visualize galaxies moving through space, and being a navigator, it's like a canoeist going down the stream with whirlpools and everything. They already know. Don't worry about all that. Just look for the V's in the water and head straight for the V's, and you'll be cool. They just know that. I know that because I was a canoeist when I was a kid. When I was a teenager, I did lots of canoeing, and I did rapids, and you don't worry about the whirlpools. You just go between the whirlpools, and you spot them by looking for where the water is converging on a V, and you'll have looked far enough ahead to maybe plot which would be the best ones for you to go through. Preferably the biggest ones. Little ones will probably cause you more trouble than the big ones. It may sound contradictory, but if you have lots of water rushing, you're going to be lifted up on top of it if you're good at balance. So I'm up to 25 minutes and 55 seconds, and the main point of this video is to say that there is a theoretical way that something could travel faster than the speed of light, and it could only occur if the vehicle itself was already traveling at the speed of light, and within that inertial frame, they projected something forward within that frame, and it would have to travel faster than the speed of light. To the outside observer looking at them also traveling at the speed of light beside them, everything would just look very normal. It would look exactly the same as if you were a car going down the highway at the same speed as a bus beside you, and you saw people tossing a ball back and forth. You wouldn't notice any difference. And Einstein, because he failed to consider absolute motion right off the bat, it screws up all his ideas and limits them to the math will be correct, but only within certain parameters, and certainly the idea of time speeding up or slowing down can't happen because time is a measurement, and measurements are constants, and as soon as your measurements become relative, nothing makes sense. That's the other problem with relativity, is when you deal at the quantum level, the quantum mechanics level of things, which is 1 micron or below mostly, we can't measure relativity. It's too small for us to measure. It's over and done with before we know it. So we take everything at the speed of light and forget about relativity unless something weird shows up. Why is that happening? A lot of people think that photons get bigger as they accelerate. That's just a fallacy of ambiguity. Photons are not particles, so they can't get bigger. They don't have mass, so they can't get bigger. What happens is the energy level increases, and it's basic math. If you get on a roller coaster, your inertia is greater than it was when you were standing on the Earth. It's the same thing with the unit of energy of the photon, which is just a way of tracking wavefronts. It's just a unit of energy and an extremely small one. I don't even know what I was talking about there. I should shut up, because if you were really interested, you're still here. If you weren't, you aren't. And I'm working on a grand unified theory, and it's so simple. Our math these days has been tied, it's gotten on a bad path with quantum mechanics, where all science suddenly has to be mathematically driven. And the problem with that is, if you don't know how accurate your data is, it's like garbage in, garbage out. You'll never know. You need to find observational ways, not just 1 or 2 or 3 or 4 or 5, but lots of observations to keep confirming that you just didn't see things the wrong way. And because of motion and relativity, it's easy to see things the wrong way. But like the canoeist in the rapid river, and a person like me as a navigator who's in blinding fog with currents that I know are extraordinarily strong, and wind motion, and you just have this all worked out in your head, and the course you're steering might be radically different than the course which would seem to be apparent to get from here to there. in navigation, and pilots and navigators will be really familiar with this. It's called a Great Circle route. You can't go from New York to London on a single course. You'll end up somewhere in Africa. That's what will happen. You have to keep changing your course as you go across the Atlantic, and you'll be going a bit further north at first, and a bit more east, and a bit more east, and eventually you'll be actually heading south. I'm exaggerating a little bit. You have to keep adjusting your compass course, and most navigators on a ship will divide. A ship can easily take 5 days to get from New York to the English Channel, so they'll just change the course once a day, and it'll be sort of a once a day they will alter the course, usually early in the morning, so the next 24 hours that's the course, and then you'll alter the course on the next 24 hours, so that by the time you arrive at the English Channel, the Land's End lighthouse will rise up over the horizon exactly where you thought it would be, exactly when you thought it would do. And I can tell you, my very, very first trip as a navigator with HMCS Cape Scott was to take Cape Scott in January from Halifax to the English Channel. We didn't have GPS. We had Loran, and it was out. There was no Loran because of the electrical storms. It was a bit too early for icebergs, so I didn't worry too much about icebergs. I did steer quite a ways away from a rock that's 200 miles south of Newfoundland, just to make sure I was at least a couple hundred miles away from that sucker. You could hit it, especially in a storm. So I was ever so happy on my 5th day, as I recall. When I'm up on the bridge, I know that I'm looking in a particular direction. You can't see anything anywhere. And this is the horizon here. And what I'm waiting for is to see a lighthouse start rising up over the horizon at exactly the bearing I hoped it would be, at exactly the time I hoped it would be. And Land's End Lighthouse was there for me. Thank you, thank you. My first trip as a navigator. And then I navigated the ship all over the place. I don't know if I got through to you. I hope I did. I may not, because of my serious health problems. I have no idea how much longer I'm going to live. I can be quite suicidal with my chronic pain. There's no hope. The treatment isn't helpful. And I'm being limited by law about the amount of drugs I can get. So opioid laws are preventing me from getting the pain treatment that I actually need, and I don't give a crap if I'm an addict because I'm 73. What do I care? That's the way it goes. There's my health issue. So I may not get a chance to write down all my theories, and even if I did, getting them published and out there is pretty hopeless. So YouTube is here. If you like this, tell other people about me. Tell them to come and put up with my long-winded videos, and I'll try to teach you why electrons set the speed of light, why nothing can ever travel in a circle on the true path of Earth through space. I've talked a lot, haven't I? I'm just killing time because I'm on my way to see my doctor today to talk about my latest serious issue, which I will not bore you with, but it's got me seriously depressed and not wanting to. I spend most of my days wishing I was dead. You don't want to be there. But I'm trying my best, like Zarathustra, Nietzsche, says, happiness can only be achieved by achieving what your heart is in. And my heart is in teaching all the boneheads out there and the idiots and non-thinkers, the ignorant masses, what I know. I'm the smartest person I know. And whether you listen, doesn't matter. Somebody will come up with it if the Earth doesn't destroy itself first, which it's going to get really nasty in the future. Really, really nasty. You're not going to want to be here. If you aren't preparing for it, it's too late. Sorry, kids, but you got a nasty future ahead of you. Expect wars. It's going to happen. I'm getting gloomy now. 34 minutes and 21 seconds. Butchie Poo is going to say goodbye. I have to reach down here and put my cursor on the stop button. It's me, Butch.